Hi everyone, this video is to run through the practice test for the matrices topic for Year 11 applications. Let's get started. Question 1. This is the calculator free section. Consider the matrices A, B, C, and D. Question A, state the dimensions of D. So dimensions, remember that is always the number of rows by the number of columns. Rows goes first. So here D, we have one row and two columns. So the dimensions of D would be 1 by 2. Question B, calculate where possible the following. If not, explain why. So 5C, we've got this matrix here, C, and we're multiplying the whole thing by the scalar 5. So this is scalar multiplication. That just means every number inside that matrix, each element in the matrix gets multiplied by the scalar. So we'll end up with 3 times 5 is 15, negative 10, 5, and 0. 2D plus 3B. Okay, so 2D is going to be this matrix here multiplied by 2, so it would be 12 over there and 4 over there. And 3B is this matrix here multiplied by 3. We don't actually need to work this out because this is matrix addition. And remember, the condition for matrix addition is that to be able to add or subtract matrices, they need to have exactly the same dimensions. So this here is impossible, as D and B have different dimensions. Okay, A take C, so A and C here, they have the same dimensions, which means we can do the subtraction. And the way it works is, remember, for matrix subtraction, we're just going to subtract each corresponding element. So we're going to get, in this first spot here, 2 take 3 gives me a negative 1. 1 take negative 2 is the same as 1 plus 2, so that's a 3. Negative 1 take 1 is negative 2, and 3 take 0 is 3. A multiplied by C. So here we've got 2, 1, negative 1, 3, multiplied by 3, negative 2, 1, and 0. So we're going to do the first row here times that first column. So we're going to get 2 times 3 is 6, plus 1 times 1 is 7. Then we're going to get first row by this, multiplied by the second column. So 2 times negative 2 is negative 4. 1 times 0 is 0. Add them together, you get negative 4. Second row, first column, we get negative 1 times 3 is negative 3. Negative 3 plus 3 is 0. And last slot here, we get 2 plus 0 is 2. Next question. The table below shows the number of overseas and local letters sent by a company over a period of 5 consecutive days. So we've got days Monday, Tuesday, Wednesday, Thursday, Friday, and for each day we've got a number of overseas letters and local letters. Represent this matrix in a represent this information in a 2 by 5 matrix M. So M here, it's going to be 2 by 5, 2 rows and 5 columns. That means that we want each row, if there's only 2 rows, we want each row to mean a number of, the overseas or local letters. So we're going to get 5 columns along here, and each one of those columns is going to be one of the days. So Monday, Tuesday, Wednesday, Thursday, and Friday. So on Monday we had 0 overseas and 8 local letters, and we're going to keep filling in this matrix in that pattern. So Tuesday we had 2 overseas and 5 local, Wednesday was 1 and 10, Thursday was 5 and 15, Friday was 3 and 6. Question B, the cost of sending an overseas letter is $3 and a local letter is $1. Show this information in matrix C that can be multiplied by matrix M to create a meaningful result. So what's going through my mind at this point is this. Matrix C could either be a row matrix, like that, or it could be a column matrix, like that. But only one of those will be able to be multiplied by M. So notice matrix M here, that was a 2 by 5 matrix. So if I'm going to do C multiplied by M, I need the number of columns in this C matrix to be the same as the number of rows in my M matrix. So let's look at, let me just make that really explicit what I'm doing here. This matrix here, this column matrix, is a 2 by 1 column matrix. So if I try and do a 2 by 1 matrix multiplied by a 2 by 5, using the trick that we've been using in class, these two numbers are not the same. Therefore, it cannot be multiplied. So that matrix is not the right one. What we need here is a row matrix. That's a 1 by 2 matrix, which we can multiply by a 2 by 5. So now I've made this all messy, but my matrix C is going to be a row matrix that looks like that. Question C. Calculate the product of the two matrices from A and B and explain what information this matrix shows. So we're doing matrix C multiplied by matrix M, which you wouldn't need to write out again here. I'm just going to do it in this video so that I can easily explain what it is that I'm doing when I do this matrix multiplication. So we're going to get a 1 by 5 matrix as a result. And for each one of these, we're going to do this row times each one of these columns. So for my first element, I've got 3 times 0 is 0, plus 1 times 8 is 8. Then 3 times 2 is 6, plus 5 is 11. Then I get 3 plus 10 is 13. 15 plus 15 is 30. And 9 plus 6 is 15. This is my product. And let's think about what this product actually represents. For each one of these, what have I done? This 3, that was the cost of an overseas letter. This 0 was the number of overseas letters sent on Monday. This 1 was the cost of a local letter, and that 8 was the number of local letters sent on Monday. So if I do 3 times 0, that will be the total cost of sending all of the overseas letters for that day. 1 times 8 will be the total cost for all of the local letters for that day. So adding them together gives me this number 8 here, which would be the total cost of all the letters for Monday. That 11 would therefore be the total cost of all the letters on Tuesday. So this whole matrix here is the total cost of all letters each day. Last part, question D. Multiplying your answer to C by another matrix T will result in a 1 by 1 matrix that represents the total cost of sending the letters over the 5-day period. Determine a suitable matrix T. Okay, so what I really want to do here is I just want to add up all of these numbers and get one number, which would be the total cost of sending all the letters across all 5 days. So if this here is a 1 by 5 matrix, then I'm going to want to multiply it by a 5 by 1 matrix full of 1s. This way, when I do this matrix multiplied by this matrix, I'm going to get 8 times 1, plus 11 times 1, plus 13 times 1, plus 30 times 1, plus 15 times 1. In other words, just adding up all of those numbers exactly how I wanted to. Now, I don't need to actually calculate that. All it wanted me to do was determine the matrix T. Moving on to question 3. Four matrices are given by A, B, C, and D. Question A, determine the value of D12 times A23. So let's just remember our notation. That's what this question is testing. When I ask for D12, that's telling me it's a lowercase d, so it's asking me for a specific element. And it would be an element in the matrix D, this one here. And the 1, 2, remember rows always come before columns. So it's in the first row, second column. First row, second column, that's a -2. In matrix A, we're looking for the element in the second row, third column. So second row, third column, that's a 4. So -2 times 4 gives me -8. Question B. It is possible to calculate one of either BC plus D or CB plus D, but not both. State which calculation is not possible and explain why. Okay, matrix B, that is a 2 by 1 matrix. Matrix C is a 1 by 2 matrix. So let's work this out. Matrix D is a 2 by 2. In order to be able to add something to matrix D, the product, the thing that I'm adding to matrix D, would need to be a 2 by 2, because remember, matrix addition and subtraction, the two matrices need to be the exact same dimensions. So matrix BC, if I calculate this product here, it's a 2 by 1 multiplied by a 1 by 2. So remember the trick that we learned in class, the middle numbers are the same, so the new dimensions are these outside numbers, so that would be a 2 by 2 matrix. On the other hand, the product CB, that's a 1 by 2, so C is a 1 by 2, multiplied by B is a 2 by 1. So the trick we learned, the middle numbers are the same, the new dimensions are the outside numbers, so that would be a 1 by 1 matrix. In order to be able to add something to matrix D, it needs to be a 2 by 2. So BC can be added to D, but CB cannot. So the question was, state which calculation is not possible and explain why. So CB plus D is not possible because CB creates a 1 by 1 matrix which cannot be added and I'm going to go over the space allocated to me here, which cannot be added to D, which is a 2 by 2 matrix. Question C. Determine the missing values of P and Q if this matrix 4P multiplied by matrix A equals 7, 8, Q. So let me just write out really clearly what's happening here. We've got this matrix 4P. Now P is just a fill-in, it's a variable because I just don't know what that number is yet. When I multiply that by matrix A, from earlier on in the question, I get this matrix, 7, 8, Q, where Q is also just a variable filling in because I don't know what that number actually is yet. Now, let's take this step by step. So if I was to do this matrix multiplication, I would start with doing 4 times 1 plus P times -1, and that would give me the first row, first column element in my product, which in this case is 7. So I'm going to write out what I just said. If I do 4 times 1 plus P times -1, that should give me a 7. We can use that to work out what P is. So 4 times 1 is 4. p times negative 1 is negative p, so ignore that scribble, that's a mistake. So 4 minus p equals 7. 4 minus p equals 7, that means that p must be equal to negative 3. So I've worked out my first variable, p is equal to negative 3. That means that this p should in fact be a negative 3. So I've got 4 negative 3 multiplied by my matrix A. Let's work out what that would actually equal. I know that my first two elements are going to be a 7 and an 8, but to work out my last element here, now all I need to do is 4 times 3 is 12, negative 3 times 4 is negative 12, add them together to get 0. So Q equals 0, and that's my second variable worked out. We're going to move on now to the calculator section of the test. For this section, you can obviously use your page of notes, and in addition, you can have a couple of calculators with you. So as always, I recommend having at least 2 calculators, one scientific, just for your quick sort of calculations you'll need to do, and your class pad for the more complicated stuff, like for this test, all of the matrix multiplications that you're going to need to do. Let's get started. Question 1. 4 brands of mobile phones, 4 different brands of mobile phones, have been rated on 3 different features. The 4 brands are denoted by Q, T, N, and M. The 3 different features are price, P, resolution, R, and speed, S. The ratings are each out of 10 and are shown in the matrix labeled A. So let's just make sure we understand what's going on here with this matrix. Down the side here, each one of these rows represents a different brand of phone. The brands are Q, T, N, and M. And across the top here, each column is a different feature that the brand is being rated on. So P for price, R for resolution, and S for speed. Question A. What does the number 5 in the matrix represent? I'm just going to move this over here so we can answer it on this side. Okay, what does the number 5 in the matrix represent? So this number 5 here is in row N, column R. So that means it is the score out of 10 for resolution for brand N. Question B. The 3 features are given different weightings. Price is weighted as 3, resolution as 2, and speed as 1. Determine the column matrix B, in which each row represents the weightings for price, resolution, and speed in that order. So it tells us that it wants it as a column matrix. So we make a column matrix that looks like this. We want it to be the weightings for price, resolution, and speed in that order. Price is weighted as a 3, resolution as 2, and speed as 1. So that is my column matrix. Question C. Determine the product A times B. Now, to save myself time in this video, I've put this multiplication already into my class pad. So I'll just show you what it looks like. Here I've done the multiplication, A times B, and this is the answer that I get. 43, 48, 45, and 42. Last part, question D. Describe what each row of matrix AB represents. So this is now matrix AB. What does each one of these numbers actually mean? So if we think about what we've done here, when we did A times B, we took these 3 numbers, 6, 9, and 7, and we multiplied it down this column, 3, 2, and 1. So what we're doing there is, for the first brand, for brand Q, we're multiplying the scores for price, resolution, and speed by the weighting of price, resolution, and speed. And that gave us the number 43. So 43 is therefore the total weighted score. 43 would be the total weighted score for brand Q, 48 would be the total weighted score for brand T, etc. So each row represents the total weighted score for each brand. Question 2. The sketch map below shows the roads linking 4 country towns. Display the number of direct paths between the towns in a matrix. So this is a route matrix. I'm going to have from and to. And each row is going to be each one of these places, so it'll be helpful if I just do everything in alphabetical order. D, E, town D, town E, F, and G, and across the top the same order again, D, E, F, and G. Now if I'm going from D to D, there is no circle road. There is no way of going directly from D to D without passing through another town first. And that's the same for all of these towns here. So I can immediately put zeros across my leading diagonal. Now let's look at each town. Town D can go directly to E, so that is a 1. It cannot go directly to F, so that's a 0, and it can go directly to G, so that's a 1. Town E can go directly to D, so that's a 1. It can go directly to F, so that's a 1, but it cannot go directly to G, so that's a 0. Town F can not go directly to D, so that's a 0. It can go directly to E, so that's a 1. And it can go in 2 different ways directly to G. There are 2 different paths it can take there, so that has to be a 2. Town G can go directly to D, it cannot go directly to E, and it can go in 2 different ways directly to F. So that is my matrix. Question B. The matrix T below shows the number of direct paths between another 3 towns. Sketch a diagram to show a possible layout of roads linking these towns. So if I've got 3 towns, A, B, and C, let's think this through. Town A, so this is my from, and this is to. So to go from A to A, I can't, and there are zeros across this whole leading diagonal here. So there's going to be no circular roads leading from one town directly back into the same town. A can go directly to B and to C each once. So there's going to be 1 road going from A to B and from A to C. Town B can go to A once, so that's along this road here. So that means that that road can go both ways. And it can go twice to C. So it can go along that road to get to C, or along that road to get to C. Town C can go once to A, so that's along this road here. But it can only go once to B. At the moment I've got 2 roads leading from C to B, which means that if it can only go once from C to B, then one of these roads has to be a one-way road. So we make one of these a one-way road going from B to C. So now I can go in 2 different ways from B to C, but only in one way from C to B. Determine T squared. So again, I've done this one already. So I put the matrix T into my calculator and I square it, and I get this matrix here. 2, 1, 2, 2, 3, 1, 1, 1, 3. Now using this matrix, we need to work out how many routes along either one or 2 paths could a motorist take if they wanted to start at C and finish at A. So let's remind ourselves what this T-squared matrix means. This matrix now shows the number of 2-step routes to get from one town to another. So for example, the fact that there's a 2 up in this top left corner here means that there are 2 ways that you can get from A back to A with a 2-step route. So if we look back at my diagram here, I could go to C and back to A. That's a 2-step route getting from A to A, or from A to B back to A. So now, if this is the matrix for the number of 2-step routes, and this original matrix T was the matrix for the number of 1-step routes, then if I want the number of 1 or 2-step routes that a motorist could take, if they wanted to start at C and finish at A, so that's row 3, column 1, there's one 1-step route, and there is one 2-step route. So, altogether, there are 2 options if we're looking at both the 1 or 2-step routes. Last part here, how many routes traveling along exactly 2 paths? So it's no longer 1 or 2 paths, it's exactly 2 paths. So we're only interested in this matrix T squared here. Could a motorist take if they wanted to finish at B? So finishing at B, that's this middle column here. And we don't care where they start, we only care that they finish at B. So there is 1 plus 3 plus 1 options. 5 altogether. Question 3. Swimming's Cool is a company which produces swimming pools. They have 3 different models of pool which they sell, and each one requires a different amount of each of the following materials as shown in matrix A below. So let's just make sure we understand what's going on in this matrix here. We've got 3 different models of swimming pool, model A, B, C, and then each one of these columns tells me how much of that specific material each of those models need. So for example, model A needs 1 sheet of fiberglass, 100 kilos of concrete, 30 tiles, and 20 bags of gravel. Question A. Swimming's Cool receives the following orders: 4 of model A, 2 of model B, and 1 of model C. Create a matrix B to represent this information, and then use matrix methods and your class pad to find the total amount of each material needed. So we've got these 3 numbers here, 4, 2, and 1. That's how many of each model we need. The question is this going to be a row matrix or a column matrix? And to answer that question, we need to work out which one of those can we multiply by matrix A. So this matrix A here is a 3 by 4 matrix. The matrix for the number of orders is either going to be so this matrix B will be, if it's a row matrix, it will be a 1 by 3, or if it's a column matrix, it will be a 3 by 1. Remember the trick we've gone through in class that I've mentioned in this video already. To be able to multiply 2 matrices together, the middle 2 numbers of the dimensions need to be the same. So the number of columns in the first matrix needs to equal the number of rows in the second one. So looking at these, it should be obvious that we need this, the row matrix, to be my matrix B. So B is going to equal a row matrix that looks like this. We've got 4 model A's, 2 model B's, and 1 model C. And then I need to do B multiplied by A. BA, so again, I've done this one already. B multiplied by A. If I do that in my class pad, that's what it should look like, how you put it in, and it gives me 12, 790, 350, and 330. So each one of those numbers there tells me the amount of each material needed. So to complete this order, I'm going to need 12 sheets of fiberglass. I'm going to need 790 kilograms of concrete. And I'm not going to finish writing this answer because you understand what I'm doing, so etc. Question B, the cost of each material are as follows. $300 per sheet for fiberglass, $50 per kilo for concrete, $5 per tile, and $70 per bag of gravel. Calculate, using matrix methods and your class pad, the total cost of the order. So if this is the amount of each material needed, and this is the cost of each material, I need to do, 12 sheets of fiberglass multiplied by $300 for each sheet, and then I need to add that to 790 kilos of concrete plus $50 per kilo, and I need to do each one of these multiplications and add them all together to end up with just one number, which is the total cost. So if matrix BA, this one here, is a 1 by 4 matrix, then to multiply that by another matrix, which is going to give me just one number, I want to multiply that by a 4 by 1 matrix. So I'm going to get each of these numbers here, and I'm going to put them in a column matrix with dimensions 4 by 1. So I'm going to get my original BA matrix, 12, 790, 350, 330, and I'm going to multiply it by a column matrix, 300, 50, 5, 70. When I do that multiplication, this is what it should look like in your class pad, this one here, and it's going to give me just a 1 by 1 matrix, 6, 7, 9, 50. That means my total cost is $67,950. Question 4. 4 students have decided to form a study group, but not everyone knows each other's mobile number. And it gives me some information here. We've got 4 students, Amy, Ben, Kai, and Dara, obviously chosen because their initials are A, B, C, and D. And it tells me for each one of these 4 people, which other people in the group numbers do they know. Question A. Create the 4 by 4 matrix M to show the number of one-stage paths for each person to send a text message by mobile phone to another person. So this is almost exactly the same as a route matrix. It's just more, it's in a different context. It's as a social interaction matrix. But if we think back to the question about the towns, this one, we can think of it in exactly the same way. If each town was a person, and traveling between each town was kind of like sending a text message to that person, then it's going to be exactly the same thing. So let's create this 4 by 4 matrix showing the number of paths. This is from, so it's sending a text message from and sending a text message to. And we've got people A, B, C, D for my 4 people in the question. Let's fill this in. Now, we've spoken about this in class before. Obviously, it is true that Amy knows Amy's number. Everyone knows their own number. But because that information is so useless, it actually doesn't help us to put a 1 there, because it doesn't actually help us to know that Amy knows her own number. So we put zeros along the leading diagonal. Now, Amy knows Ben and Kai's number. So we can have a text message sent from Amy to Ben and Kai, but not to Dara. Ben only knows Dara's number, so Ben cannot send to Amy or to Kai, but can send to Dara. Kai only knows Amy's number and Ben's number, but not Dara's. And Dara only knows Ben and Kai's, so not Amy, but Ben and Kai. Question B, calculate M squared. So if that is my matrix M, then M squared, I'm just going to put that into my calculator like that, and it's going to give me this matrix here. So the answer there, you just read it straight off your calculator. Question C. Explain whether or not Ben can get a text message to Amy via another team member by referring to an element of M squared. So this m squared, the same way as with my root matrix for pathways between towns, this m squared now refers to the number of two-step ways that we could get a text from one person to another. So to get a text message from Ben to Amy, that is from Ben to Amy, so that is element M, row 2, column 1, that equals a 0 for the m squared matrix. Therefore, Ben cannot message Amy via another person. Question D. Calculate m cubed and explain what the significance of the number in the second row and first column of m cubed means. So again, I'm going to use my class pad. I put in m cubed, so that's my original matrix M. I cube it, and it will give me this matrix here. So the first thing I'm going to do is write that in. That'll give me a mark. And now it wants me to explain the significance of the number in the second row, first column. That's this number here. Second row, first column is a 1. So the fact that it's a 1, this means that we're going from Ben to Amy. So that 1 means that Ben has one way of messaging Amy via two other people. Because this is m cubed, so it's a 3-step route. It's going to go from Ben to one other person, from that person, so from Ben to another person, that's step 1, from that person to a second person, that's step 2, and then from that second person to Amy, that's step 3. So Ben can get a message to Amy via two other people in one way. Let's go through this last question now. At an end of year party, some people have brought gifts to give to others. Matrix G has that information. So let's just make sure we understand what's going on in this matrix here. We've got 4 people, A, B, C, and D. And same as always, it's like from down here and 2 across there. So there's a 1 in this spot here, for example. That means that person A has brought a gift for person B. So this person has a gift for this person. If there is, let's say, a 0 over here, it means that person B has not brought a gift for person A. Question A. Answer the questions about information displayed in the matrix. What information is provided in row 2, column 1? So that's the one we just looked at. Row 2, column 1. There's a 0 there. That means that B has not brought a gift for person A. Question B, question part 2, question A part 2. Who brought the most gifts for friends? So if we look across here, person A has brought 3 gifts. Person B has only brought the 1. Person C has brought 2, and person D has not brought any gifts. So person A has brought the most. Part 3, how many gifts did C receive? So to see how many C received, now we need to look at the column. C got 1 from A and 1 from B, so C has received 2 gifts in total. One person received the same gift from a friend as he gave to that friend. Who was that person and who was the friend? So we're looking here for symmetry. So for example, these two are in corresponding, we're looking at symmetry across the line of the leading diagonal here. So if there's a 1 there but a 0 there, it means A has brought for B but B has not brought for A. We're looking where someone has brought for someone else, and in the corresponding but opposite place in the matrix, that other person has brought for their friend as well. So we can look through here. A has brought for C, and C has brought for A. So that one there is the one we want. I'll just run through to show everyone kind of the rest of them to make sure that there isn't another one that's going to trip us up. So A has brought for D, but D has not brought for A. And we could go through and do the same thing for all of them. B has brought for C, but C has not brought for B, etc. The only one where they've brought for each other is for person A and person C. Calculate G squared. So again, I've put this into my calculator already. I've put in the matrix G and squared it, and it's going to give me this matrix here. Last question, is there a meaning to G squared in the context of this question? So remember, generally for root matrices, when we square them, it gives us the number of two-step roots. So for this question 4 here, it was about sending a text message via someone else to the person we want to get it to. In the context of giving gifts, it doesn't really mean anything because, for example, there's a 0 here, right? So that technically would mean that A, if we're looking for a way that A is connected to person B, it might be that, A has not brought a gift via someone else. It doesn't really fit. This is totally meaningless. All we're interested in is who has brought gifts for other people. And so there isn't really such thing here as like a two-step route that you could take. So there is no meaning to G squared in the context of this question. If anything wasn't clear in this video, feel free to either email me or write something in the comments below, and I'll try and respond as soon as I can. Hopefully this was helpful and clear to everyone.